So, have you ever wondered how a tiny string of just 5 characters can act like a digital lockpick? I mean, how could less than half a dozen keystrokes completely compromise an entire database, just spilling all its most closely guarded secrets? It honestly sounds like magic, or maybe something straight out of a Hollywood heist movie. But actually, scratch that. It's not magic at all. In the realm of cybersecurity, it's a very real, very prevalent vulnerability. Welcome to This Explainer. I am super excited to have you here today because we're going to do something actually really fun and highly practical. We are going to conduct a step-by-step digital heist. Using a real lab environment from Port Swigger, we're going to break down exactly how one of the most infamous web vulnerabilities actually works under the hood. Okay, let's dive right into this. All right, Section 1, the basics, CTFs, SQL, and SQLI. Before we case the joint and execute our exploit, let's just quickly get our foundational terminology locked in. First up, we've got Capture the Flag, or CTF for short. In cybersecurity, platforms like Port Swigger provide these simulated websites that are intentionally riddled with vulnerabilities. As players, we basically hunt for these weaknesses to capture a digital flag, which proves we successfully hacked the system. It is literally the ultimate training ground to develop your analytical thinking and practice real-world hacking techniques, completely legally and safely. Next up, we really need to understand the language of our target, which is SQL. That stands for Structured Query Language. Simply put, this is the programming language that applications use to communicate with their databases. So whenever you log in somewhere, or search for a product, or update your profile, the application is using SQL to manage and retrieve that critical information from the database vault. And that brings us to the main event, our attack vector, SQL Injection, or SQLI. This is a technique where an attacker exploits improper input validation. So instead of just giving the application normal data, like a standard username or search term, we inject actual SQL commands. Because the app doesn't sanitize our input properly, it accidentally executes our malicious commands. This allows us to modify the query structure, bypass authentication entirely, and extract sensitive data that we have absolutely no business seeing. Moving right along to Section 2, casing the joint, the e-commerce target. Now that our toolkit is ready to go, it's time to actually look at our specific mark for this exploit. Okay, take a look at this. This is our Port Swigger lab environment, which simulates a completely typical, everyday e-commerce website. Notice those category filters up at the top? Things like accessories, corporate gifts, lifestyle. From a normal user's perspective, clicking on that gifts category is completely harmless, right? You click the button, the page refreshes, and it shows you gifts. Simple. But behind the scenes, that simple click is sending input directly to the application's backend. And here is the hidden backend reality. When you click that button, the application takes the word gifts and just drops it right into a SQL query that looks exactly like this. Let's read it together real quick. Select all records from the products table where the category is gifts and the product is marked as released, meaning released equals 1. The database executes this command, and naturally, it only returns the gifts that are officially available for the public to buy. But we aren't normal users. We want to see the unreleased products. We want that hidden catalog. And that brings us to Section 3, forging the key, crafting the SQL payload. We need to forge a very specific payload to bypass that released equals 1 restriction. Enter the star of the show, our classic 5-character SQL payload. Single quote, space, OR, space, 1 equals 1, dash, dash. That is literally all it takes. We're going to inject this highly specific string of characters directly into the website's URL, right where the category name usually goes. The anatomy of this exploit is brilliantly simple when we actually break it down step by step. Step 1 is that single quote. In SQL, single quotes tell the database exactly where a piece of text begins and ends. By injecting our own single quote, we artificially close the category string early. We're breaking right out of the data field and into the command field. Step 2 is the tautology, or 1 equals 1. A tautology is just a statement that's always mathematically true. 1 always equals 1, right? By adding this, we are telling the database to return records if the category matches or if 1 equals 1. Since 1 always equals 1, this condition evaluates to true for every single product in the entire database. And finally, step 3 is the comment, that double dash. In SQL, 2 dashes just mean ignore everything that comes after this on this line. And looking at this brilliantly illustrates the devastating impact of those 5 characters. Check out the original query on top compared to our injected query on the bottom. We essentially replaced the word gifts with our payload. So the query now reads, select products where category is an empty string or where 1 equals 1. And because of those 2 dashes at the end, the database completely ignores the end released equals 1 rule. It's effectively deleted from the command entirely. We have completely tricked the database into returning all records while ignoring the release status like it was never even there. All right, we've cased the joint, we've forged the key. Now for section 4, the execution, bypassing the filter. To launch this attack, we simply navigate over to the category filter and modify the URL directly in our browser's address bar. We just type our payload right in there and hit enter. And boom, the application reloads, but this time the restriction is completely bypassed. The application dumps the entire, unreleased, hidden catalog straight onto our screen. You can even see the green lab solved banner pop up at the top. We've successfully manipulated the database into giving us unauthorized data. It's a massive security failure, literally executed in seconds. So we broke in, but as ethical learners, we really got to pivot from the mindset of a hacker to the mindset of a security architect. Let's move to section 5, securing the vault, defending against SQL. How do we actually patch this vulnerability so our own applications don't fall victim to this exact same trick? To protect sensitive data, developers must absolutely fundamentally change how they handle user input. The golden rule here is that user input should never, ever be directly concatenated or glued into a SQL query. Instead, you've got to use what are called parameterized queries or prepared statements. This forces the database to treat whatever the user types strictly as data, not as executable code. So even if they type or 1 equals 1, the database just thinks they're looking for a product literally named or 1 equals 1. Beyond that, you've got to implement strict input validation to block unexpected characters. And finally, always apply the principle of least privilege. The application should only have database permissions for the exact data it strictly needs to function, nothing more. I mean, if the app itself can't read the admin passwords, an attacker exploiting the app can't read them either. We have definitely covered a lot of ground today, from understanding the core basics to executing a real exploit and learning how to defend against it. Let's look at section 6, your next steps. Join the cybersecurity community. I really hope you found this technical walkthrough as fascinating as I did. If you enjoyed this explainer, please make sure to drop a like, share it with your fellow tech enthusiasts, and drop a comment below with your suggestions for what vulnerabilities we should break down next. The absolute best way to learn this stuff is by actually doing it, so please check the description right now for the direct links to the Portswigger lab so you can try this exact SQL injection challenge for yourself. Before we go, I want to leave you with one final, crucial question to chew on as we wrap up. Think about the projects you're working on, the code you write, or the systems your company relies on. If someone injected those 5 simple characters, quote, OR, 1 equals 1, dash dash, into your application today, what would actually happen? Until next time, stay curious and stay secure.